Time for another lesson. This is another technique of integration, and it's extremely powerful. If you couple this with integration by substitution and then the basic forms that you learned in 5 Things to Know, you're going to be able to integrate most of the things that you'll encounter. So this is called integration by parts. And I've started off with some theoretical justification for integration by parts. At least this shows you where integration by parts comes from. So I'm using two dummies up here. I'm using u and v, and they're expressed as functions of x. So we'll let u and v be functions of x, and then we'll remember how we differentiate a product. And we learned this some time ago. But if I've got u times v, and I want to take the derivative with respect to x, that's equal to the first times the derivative of the second plus the second times the derivative of the first. At least that's the way I remember it. Now, that gives me the expression that you see here. What I'd like to do with that is to integrate both sides. And when I take the integral of the derivative of u times v, it's an indefinite integral, so taking that integral just says, what do I have to differentiate to get the derivative of u times v? Well, clearly u times v. Now here I've left off the x's, but we know that u and v are functions of x's. And so I've got uv as the integral of the derivative of the product u times v, and that's equal to, this equal and this equal go together, that's equal to u of x, and then dv dx is just v prime. So it's u v prime dx plus v u prime dx. This is just u prime. Now if we'll rearrange this line here, we'll get u v prime dx is equal to the product uv minus the integral v u prime x dx. So you say, so what? And I think that's a legitimate thing to say. But here's the impact. I have on the left-hand side a form, integral of u v prime dx. And I can assign u and v to the different parts of that, as you'll see in just a second. But if I don't know how to take this integral, if I don't see immediately what that is, I know that it's equal to the product of the function u and v minus the integral of v u prime x dx. So maybe I know how to integrate this. Maybe this one's easy for me. And of course our strategy will always be move to where things are easier. And we can even do one little more bit of simplification here, because recall that for v, a function of x, dv is equal to v prime x dx. So using that notion, this is the definition, in fact, of the differential. It's the derivative of the function times the increment, or the differential for x. So using that notation, a final thing we could add here would be the integral of u dv equal uv minus the integral of v du. So just remember that, and that's the classic form for integration by parts. So let's do an example. This example is the integral of x minus 1 e to the x dx. And if you'll reflect on what you know about taking integrals to this point, you don't have anything in your toolkit that will let you integrate this. So here is the part of integration by parts that takes the most insight. We have to decide on what's going to play the role of u and what's going to play the role of v. And I see basically 2 choices here. And here's choice 1. I could let u equal x minus 1 and let dv equal e to the x dx. If I did that, then du would be equal to dx, just taking differentials here. And now how would I find v? V would be equal to the indefinite integral of e to the x dx. I mean, if I've got dv equal to e to the x dx, then if I take indefinite integral of both sides, I get v on the left and e to the x on the right. What was my other choice? My other choice, and let's write or, my other choice would be to let u be e to the x and dv to be equal to x minus 1 dx. And if I did that, then du would become e to the x dx, and v, same process as above. I would just have to take the indefinite integral of the left and right hand sides. And what about the indefinite integral of x minus 1? Well, that's going to be x minus 1 squared over 2. You might have to think about that a bit, but that's okay. I've got two choices in assigning u and v, and one of those choices, namely the top choice here, looks like it simplifies things. Du is just dx, that's pretty simple. V is e to the x, that's real simple. But things get more complicated if I make the second choice. And so what I'm thinking about doing is putting a contour around this and saying, no, no. What I want to do is to say that then I is equal to, now I'll write it in symbols once, and then we'll make the substitution, uv minus the integral of v du. So this is going to be equal to, x minus 1 e to the x, substituting u and v from u and v, minus the integral of what's my v function. My v function is e to the x, and du, well, du is just dx, so this would be du dx. And that's equal to, well, this is just, there's no integration to take part here, so this is x minus 1 e to the x. And can I evaluate the integral e to the x dx? Sure. That's just an e to the x. And then this is finally plus a constant. And then I can, if I need to, I can rewrite this a little bit. See, I've got an e to the x here, and I've got one there, so I could factor that out. And this would become an e to the x minus 1 plus a constant, or e to the x minus 2 plus a constant. And proof is in the pudding. Well, one just needs to differentiate here and see if we get the integral that we started with, this value right here. So we'll be back in a minute. Now we've seen that the integral we started with, I, was equal to e to the x minus 2 plus a constant. And I guess I should have written this first, but what was I? I was equal to the integral of x minus 1 e to the x dx. And so integration by parts has led us to the belief that this piece right here is an antiderivative of this thing right here. That's what the process of taking an antiderivative is. And so, does it check? Well, let's see. All we'd have to do is to take the derivative of e to the x minus 2 plus c dx. And if we're correct that the integral is equal to this term right here, then when I take the derivative, I'll get this piece right in here. So let's see. Now what have we got? I've got a product of functions here, and so I'll take the product rule as my guide for how I differentiate these. And we remember the product rule as the first function times the derivative of the second. Now the second has a very simple derivative, doesn't it? X minus 2 has a derivative just equal to 1. So it's the first times the derivative of the second plus the second, x minus 2, times the derivative of the first. And the first is e to the x, and e to the x is a function that's its own derivative. And then plus the derivative of the constant on the end, but the derivative of a constant is 0. So this is equal to, now it's just a matter of cleaning up, multiply by 1, factor out an e to the x, I guess, is probably the best way to do this. So e to the x, I've got 1 plus x minus 2. The derivative of the constant is 0, so we'll let that go, equals e to the x 1 plus x minus 2 equals e to the x 1 minus 2 is minus 1. And if you want to get it exactly like it was in the integral, x minus 1 e to the x. So it checks out. Our check was okay. See you in the next lesson. Thank you.